Hello and welcome to a supplementary video on the names and properties of two-dimensional shapes. Okay, so in case the previous video wasn't too convincing, let's just construct a regular polygon. Well, I can't really construct a regular polygon, but I'll construct a polygon and we'll use our imagination to pretend that it's a regular polygon. Okay, so first of all, what do we remember about our naming of polygons? This has got 1, 2, 3, 4, 5, 6 sides. So therefore it's a hexagon. Okay, now I went through some maths to explain why the external angles all add up to 360 degrees. Another way we could have explained it is if I extend this line, then this is our external angle here, and then if I extend this line, then this is our external angle here, and if I extend this line, then this is our external angle here. And if I extend this line, we'll pretend that's a nice neat line. While we're playing pretend, let's pretend that I've actually got some sort of artistic talent. No harm in pretending. So we'll extend this line, and we'll extend this line. And now if we try to add these up, that's a lousy circle, but you can see we have come full circle. So the exterior angles just visually look like they should be 360 degrees when you add them all up. Now one question is, well, why can't we make the same argument with the internal angles? Because look, you could imagine just walking down the slope and turning round and walking and walking and walking and walking and walking, and you end up back where you started. But that argument actually doesn't apply, because if you start anywhere and start walking all the way around, you're turning through 360 degrees, but that's not the same as the sum of these angles. And let me try and make that clear by drawing straight lines from the vertices. Yes, that's not a regular polygon because that didn't actually appear into a point, but you might be able to see no, that doesn't look right. Let's try and pretend that this is a regular polygon and that we've come out from the centre. See, as you can tell, this only really applies to a regular polygon, but there we go. So we're pretending that these all radiate from a central point. So now you can see if we go around the outside, we're actually turning through 360 degrees. We're actually covering these angles here. So these are the angles that add up to 360 degrees. I'm calling them X. But all these angles here are your 360 degrees. Now if this were a regular polygon, or a regular hexagon in this case, but any regular polygon, then the length of this line would be the same as the length of this line, which is the same as the length of this line, which is the same as the length of this line, which is the same as the length of this line, which is the same as the length of this line. So what we have here is 6 isosceles triangles. Now because it's an isosceles triangle, if this angle here is x, then these two angles must be the same, and they must be, or the sum of these two angles must be 180 degrees minus x. So these are actually 180 degrees minus x over 2. But again, because it's a regular hexagon, or any regular polygon, because these lengths are all the same, and this is an isosceles triangle, then these triangles must all be congruent. So this angle must also be the same, and 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 this angle must also be the same. So all these angles are the same. Let's call them y. So all these angles are y. Whoops, and this angle must also be the same. Aha. So these angles are all y. Now look at these two y's here. They actually sum together to make the internal angle. So we've got two y's here plus x all have to add up to 180 degrees. So x plus 2y is equal to 180 degrees. But 2y is equal to the internal angle, or interior angle, whatever. Let's say internal angle. So x plus the internal angle, I'm just going to call it internal because it's taking too long to write, is equal to 180 degrees. But we already know that the internal angle, I'm just going to call it int, plus the external angle, I'm just going to call it x, is equal to 180 degrees. So this x is actually the same as this x here. So that argument of why can't we just walk around the inside and go all the way around in a circle, that sort of does actually work, but it's the external angles that you're rotating through, not the internal angles. The internal angles are actually supplementary to the external angles, which all add up to 180 degrees. Okay, I hope you found that explanation helpful. I'd like to wish you all the best with your revision and all the best with your exams, and I look forward to seeing you in another